Welcome to this section on electric dipole. So first we'll see what is electric dipole is. So electric dipole is nothing but two equal charges. The charges magnitude is equal but opposite in sign. Okay. So let this be a negative charge and this be a positive charge. Both charges have equal magnitude but opposite sign separated by a small distance of 2a. Okay, distance is equal to a short distance of 2a. So electric dipole is nothing but a pair of two equal but opposite sign charges separated by a small distance. Okay. So due to this negative charge and due to this positive charge, there will be an attractive force between these two charges. Okay. And the electric field produced by this electric dipole can be defined by electric dipole moment. Okay, so electric dipole is moment is nothing but that gives the strength of the electric field produced by the electric dipole. So the electric dipole strength, okay, electric field strength can be found by electric dipole moment denoted by letter P. So which is equal to Q into the length. Okay, Q is the charge and L is the length between the two charges. So Q into L is equal to 2A. So Q into 2A is the magnitude of dipole moment. And the direction of this dipole moment is from negative charge to positive charge. Okay, this is the representation of dipole moment. So electric dipole moment is a vector quantity and its direction is from negative direction to positive charge, from negative charge to positive charge. So electric field will be opposite to dipole moment. Electric field direction will be opposite to electric dipole moment. Okay, so electric field always the direction will be from positive charge to positive to negative will be the direction of electric field, whereas the direction of the dipole moment, yes, which gives the strength of this electric field, is given from negative to positive. Okay, so electric dipole moment will give you the strength of the electric field by the electric dipole. So electric dipole is a pair of equal and opposite charges. Okay, let's see the first question. The electric dipole is a pair of, just now I told, right, electric dipole is nothing but a pair of equal and opposite charge, right? So separated by a small distance. So come on, what could be the answer now? Two equal and unlike charges? No. Two equal and unlike charges? Two equal and like charges, unequal and like charges, unequal and unlike charges. So unequal and unlike charges, it is wrong. Unequal, no, both the values will be same, magnitude will be same. So C is also ruled out, D is also ruled out. Two equal and like charges, no, they are not like charges, they are unlike charges, right? So option is A. Two equal and unlike charges is the answer. Next, come to next question. The electric dipole moment is a scalar quantity, true or false? No, the electric dipole moment is given by the product of the charge into the distance between them, right? So it is a vector quantity which represents the direction from negative charge to positive charge. From negative to positive charge, the dipole moment direction is there. Okay, which gives the strength of the electric field produced by this electric dipole. So electric dipole is false. It is a vector quantity. Okay, and the unit for this electric dipole will be, for charge it is coulomb and for distance it is meter. So unit for dipole moment. Okay, we have the unit of coulomb meter. Next, orientation of dipole moment P in uniform electric field. Okay, E is in stable equilibrium when the angle between E and B is. Okay, so assume uniform electric field from the charges. So fields are uniform. So electric field lines will be equally spaced. Okay, now they are asking that whether dipole moment P and uniform electric field E is in stable equilibrium. When they will be in stable equilibrium. Okay, so when the charge be negative here, let the charge be positive here. Okay, now the dipole moment direction will be this direction and the electric field direction is here. Okay, from the electric field is due to some point charges and this field is uniform. Okay, and the dipole moment is P. Now both P vector and E vector, okay, P vector and E vector are parallel. Okay, so when they are parallel, what could be the angle between them? The angle will be 0 degree. Okay, so the angle between them will be 0 degree. This will be the condition for stable equilibrium. Okay, so it is given by torque is equal to PE sin theta. Okay, theta is equal to 0 degree. Therefore, the torque also will be equal to 0. So answer is B and E are parallel. We have a stable value and theta is equal to 0 degree. So option is A for stable. When both are in anti-parallel, right? P and E in opposite direction, then we have unstable condition. Now the question is two charges each of 0.1 microcoulomb but opposite in sign. Okay, so 0.1 microcoulomb but opposite in sign. Okay, so one is negative charge, another one is positive charge. So the electric dipole is we have equal charges but opposite sign. Okay, so they mean it is an electric dipole. Two charges each of 0.1 microcoulomb but opposite in sign are 1 millimeter apart. So 1 millimeter. So which is equal to 10 to the power of minus 3 meter. Okay, now we have to find the magnitude of dipole moment. So magnitude direction will be from negative to positive is the direction of dipole moment. So magnitude of the dipole moment P, okay, is given by Q into 2A. Okay, so what is Q? Q is the charge which is 0.1 into 10 to the power of minus 6 into 2A value is into 10 to the power of minus 3 meter. Okay, so just multiply this and you'll get the answer. Okay, so 0.1 and 10 to the power of minus 6 into 10 to the power of minus 3, you'll get it 10 power minus 3, 6 and 10 power minus 3, you'll get it as into 10 to the power of minus 9. Okay, and just you can see the option they are given us in terms of 10 power minus 10, 10 power minus 9. So just you make a small adjustment according to the answer into 10 to the power of minus 9. So just multiply and divide it by 10. Then we'll get it as 1 into 10 to the power of minus 10, okay, meter, coulomb meter. Okay, so option will be A. So this is the value for the dipole moment. Okay, so and the option is A. So we know the expression for the formula to find the magnitude of the dipole moment. Just substitute the charge value and just substitute the distance value, then you will get this answer. Okay. Now the intensity of electric field E depends on distance r due to a dipole is related as. So you have to find the relation between electric field and the distance from a point. Okay, electric field due to the dipole and at a distance r, you have to find out what is the relation between the intensity of electric field and the dipole at some distance r. So this is the formula which gives you the relation between the electric field E and a distance r. So from this formula, E is equal to Kp. K is the Coulomb's constant. Okay, P is the dipole moment divided by R cube will be the distance. Okay, distance at some point due to this electric dipole. So let it to charges. Okay, minus Q1 plus Q is there. Okay, and at some distance you have R be some distance from here. Okay, now we have to find out what is the electric field at some distance R due to this dipole, and this could be the formula. So from this we understand that electric field and distance are inversely proportional. They are inversely proportional to 1 by R cube. Okay, so the option will be B.